Now in section 6.6, we're going to talk about the approach on factoring. We've basically seen all the factoring. We're just going to take a quick approach. So the first thing we're going to look at is, why do we have a binomial? So two terms. Binomial are actually tricky. Those are the trickiest because sometimes it could be as simple as just a common factor. Just factor out a greatest common factor. So I know when we covered this, I call this undoing the distributive property. So looking at question or my example 8, I can divide both of them by 9. So I'm going to have p plus 5. All right, there's nothing I can do to the p plus 5, the inside. So it was just a common factor. Looking at my example b, numbers wise, I can divide both of them by 4. Letter wise, I can divide them by m and p. Remember, I always go for the smallest exponent. Now, if I divide both of them by 4 and p, on the first one, I'm going to have 2mp and then plus 1. I cannot divide anything else, so that was pretty much it. Or sometimes it's a little bit factored already. We have common parentheses. So my first factor will be a plus b, because it's the same parentheses. So in fact, let me show you guys this. If I cancel it, because I already used it, my second parentheses, do you guys see it where it is? Like right there, 5x minus y. That's basically it. So sometimes it could be as simple as just a factor. However, it's not the only way. Like, that's what I said. Binomials could be tricky because this could be easy. But what if I don't have a common factor? I see here I cannot divide 64 and 9 by anything, other than 1, but my numbers don't get smaller. I cannot factor a letter, so there's nothing to factor. Then in that case, probably we have one of the special cases. It's either the difference of the squares, the difference of the cubes, or the sum of the cubes. Here, because I see to the second power, I'm going to try to go difference of the squares. The first part, 64m squared, let me write that as 8m all squared minus 3n all squared. So I was able to write it as a difference of the squares, right? I call difference of the squares because it's a minus, and both before and after the minus are squared. So my factoring are going to be 8n 8m minus 3n. Let me erase that to make it look better. So it will be 8m minus 3n, and the other factor will be 8m plus 3n. Remember that when we have difference of the squares, the parentheses look similar. It's just that one of them has a minus, the other one has a plus. Now looking at my example B, because my exponent is to the third, I'm not going to have difference of the squares, right? There's no factors, so there I cannot have a common factor. I don't have the difference of the squares. However, because it's to the third, I can try to do it the difference of the cubes. Let me rewrite this as 2p all to the third minus 3 to the third. All right, for difference of the cubes, we said that it's going to be a little tricky. The first part, the first parenthesis is going to be 2p minus 3. The second parenthesis, since this one starts with 2p, right, squared it, so 2p times 2p will give me 4p squared. It finishes with a minus 3, so, or negative 3. So negative 3 times a negative 3 will give me a plus 9 at the end. Remember, the second parentheses, square the first term to see the beginning, square the last term to see the ending. Now, for the middle term, opposite sign, right? So this is a minus, I'm going to put a plus sign. And then multiply these two terms. 2p times 3 will give me 6p. So that's my factoring. So remember, when we see a binomial, so two terms only, probably just a simple factor. Just factor the greatest common factor out. That's basically it. It could be the difference of the squares. Or it could be the difference of the cubes. Or it could be the sum of the cubes. Because remember, for cubes, it doesn't have to be minus. It could be plus. Like I said, binomials can be tricky. Now, trinomials. The diamond thing will always work. Will always work. Let me take a look at this one. I'm looking for two numbers that multiplied equals 25, added equals to 10. It could be 5 and 5. So my factoring, just to start with, I'm going to go p plus 5, p plus 5. Or I'm more like, well, it's the same parentheses. I'm just going to call this p plus 5 squared. One way we could have noticed that it was a perfect squared, because the leading coefficient is 1, the square root of it is 1, the square root of the last number is 5. If I multiply these two numbers, 1 times 5 gives me the half of the middle term. So that's one thing I should have known, that it was a perfect square. Let me try that here on example B. The square root of 49 is 7. The square root of 9 is 3. When I multiply these, 7 times 3 gives me the half of 42. So I have a perfect squared. So matter of fact, I'm not going to do the diamond. It will work. By all means, it will work. You know, I'm looking for two numbers that when I subtract them equals negative 42. And when I multiply them, it's equal to 49 times 9. But I already know it's a perfect squared. I just checked it. So it's going to be 7z minus 3 all squared. I have a minus because this sign in the middle is what tells me what I'm going to put. Notice how here that we had a plus and we finished with a plus sign in the middle. So that sign in the middle will tell me whether it's a plus or minus inside my parentheses. Okay, so trinomial, we have the special cases, you know, the perfect squares. But if we don't remember those, the diamond thing will always do it. Now, why do we have four terms? Why do we have four terms? Then, first of all, let's factor it, you know, by grouping. I'm looking at my first two. Let me divide both of them by 2. And I'm going to have 2 minus q. On the second one, the second group, let me divide them by negative 3p. So I'm going to have 2 minus q. My parentheses are common, 2 minus q. And then my second parentheses will be 2 minus 3p. So grouping, we do the first two and then the last two. Now let's take a look on my example B. The first two terms, actually let me use red so we don't get confused with example A. First two terms, I can factor out a 4k squared out of it. So I'm going to have 5k plus 1. Looking at the second group, I can factor a negative 9 out of it. So I'm going to have 5k plus 1. So my factors are going to be 5k plus 1 and 4k squared minus 9. One thing though, whenever we have a squared inside of parentheses, or it could be a cube, double make sure you don't have one of the special cases. Because remember, binomials can be tricky. Well, you can factor the greatest common factor out of it, or in this case, I can rewrite this 4k squared minus 9. I can rewrite that as 2k squared minus 3 squared. So in this case, the second parentheses, it is the difference of the square. So make sure you break it up. The first parentheses, I'm not doing anything to it. So I have 5k plus 1, right? Nothing to it. The second parentheses, I'm going to have 2k minus 3 and 2k plus 3. So remember, binomials could be tricky. Could be just a common factor. It could be the difference of the squares. It could be the difference of the cubes. It could be the sum of the cubes. So when we have only two terms, that can be tricky. Three terms, the diamond will work unless we can tell it's a perfect square, then we have a shortcut. Four terms, like we started in this case, do it by grouping.